Okay, so this is Jacobian. Jacobian is almost the same with inverse kinematics. Inverse kinematics, we need to calculate the end position. We need to calculate the motor position. But Jacobian, we want to calculate the velocity of our end effector. So we want to calculate this velocity in terms of velocity of x, velocity of y, velocity of z, velocity of roll, pitch, and yaw. Okay. Ada gangguan sikit. Okay. So we are trying to calculate this six velocity, and this six velocity is the velocity of our end effector. Okay, the speed of our end effector. Why it is important? Let's say we want to grab something. So something is moving with a certain velocity. Our robot arm must able to move at a certain speed so that it can capture the object that is moving. Okay, and velocity is also important. Let's say you want to play ping pong, so you need to calculate the velocity of the ball, and you need to calculate the velocity of your end effector so that you can play the ping pong. Because you don't want to push the ball too hard, you need to have a certain speed of velocity. Okay, kita tak nak laju sangat, kita nak pukul lembut saja kelajuan dia. Okay, so we want to control the velocity of our arm robot. How about this one? This one is a moving conveyor. So the car is moving with a certain velocity, and our robot arm needs to paint this car while it is moving. So the robot arm also need to move at a certain velocity. So in this case, we cannot use inverse kinematics to control our robot arm. We need to use Jacobian. If we don't have Jacobian, we cannot paint this car while it is moving. Okay, so Jacobian is very important. It is one of the things uh, that makes that enables our robot to work while our conveyor moving. Okay, so if you use the all methods, the car needs to stop here first, then the robot will do the painting, right? But in this case, the car doesn't need to stop. The conveyor will keep on moving, and the robot can paint our car. So by doing this, we can make sure that our car can be completed much more faster. Okay. So what is the Jacobian? Jacobian, what is it? Okay, simple. Let's say you have a car. The car is moving this way. At the time 0 second, the car position is 0 meter. When the car, when the time is 2 seconds, the car position is 2 meter. So velocity. What is this car velocity? Okay. Okay. Please everyone try this. Okay. What is the velocity of this car? Okay. Siapa dapat? Okay. I think you can still see it.
Satu doktor.
Okay. 1 meter per
1
second.
meter per second.
Okay. So how did you do it?
Jarak bagi masa.
So good. Okay, perhatikan. So to get the velocity, you just need to divide the distance over time, right? So distance is 2 divided by 2 seconds. So the speed is 1 meter per second. So what we do here, we need to find the dx, the change of position over time, dt. Okay, so it is dx per dt is equals to velocity. If you remember previously, if the position x is a position, oh sorry, x is position, to get the velocity, we just need to differentiate dx over dt. Betul tak? Is it correct? Do you agree with me? Okay. So to change from position to velocity, we just need to differentiate with time. Ingat tak? Kan? So the same concept for our robot arm. It is very simple. We just need to differentiate our robot position. Okay. Okay. So a little bit more concept on the Jacobian. Okay. The what we're trying to get is the velocity of this part and effector. So what will happen? We need to get the combination of speed from motor 1. So let's say the motor 1 is moving like this, and motor 2. So the combination of the velocity from motor 1 and velocity of motor 2, we can get the velocity of our end effector. Okay. So so I will show you some example here. Okay, look at my screen. Tengok saya punya screen . So no background. Okay. So this is my end effector. Okay. So this is my end effector. If I move this this motor here, the end effector will move with a certain velocity, right? Okay. What happens if I move this motor and this motor together? The velocity of the end effector will become much more faster or slower?
Faster.
Faster, right? Okay. So when we move one motor only, the velocity is not that fast. But if we move more than one, the velocity will become very fast. Okay. So the end effector velocity depends is the combination of the velocity of each motor. Okay. So semua motor ni contribute kita punya end effector velocity. Okay. Because of that, we need to do the calculation. We need to find the contribution of each motor. What is the contribution for each motor to the end effector? Okay. So how can we do that? Okay. So first we know that our robot arm, there are two parts, which is linear velocity and angular velocity. So let's say this is my robot arm. Okay. So first we have the velocity of x, y, and z. So velocity of this type of movement towards y, this way, movement towards x and z. And then we have the rotation, which is roll.
Kita tak nampak pun apa pilihan slide.
Tak nampak eh?
Tak.
Oh, dia dah terkeluar terus eh. Okay, nampak? Okay, so our robot arm have two velocity, which is the linear velocity and the angular velocity. Okay, so linear velocity is the z, y, and x. Okay, so let's say this is my robot and effector, or you can call it gripper. Okay, so we want to find the velocity of this gripper in terms of x movement, y movement, and z movement. Okay, this is called the linear velocity. And then we also want to find the velocity in terms of roll, pitch, and yaw. Okay, so the roll, pitch, yaw, the roll, pitch, yaw, angular velocity for this robot arm. So we want to calculate these two things. So to do the calculation, it is not that hard actually. So what we need to do is, okay, yang ni, I will skip this to the practical part. So what we need to do is just simple. First, we need to obtain what is the px, py, and pz from our DH matrix, which is the n effector. So this is the fault kinematics. By using fault kinematics, we can get the n effector n position. Okay, if you remember, if x is position, if we differentiate dx per dt, we can get the velocity. It is the same thing. For the forward kinematics, we can get the px, py, pz, which is the position of our robot arm. If we differentiate all of this with dt, we can actually get the velocity of this robot arm, which is called Jacobian. So what we need to do is we need to differentiate px with dt, py with dt, pz with dt. Okay, then we can get the arm velocity. Okay, so here I want to show how we can do that. Okay, let's say this is your 3-degree of freedom robot arm. Okay, the robot arm can move this way and this way, and a prismatic, and the third link is a prismatic movement. Okay, ke depan ke belakang. Okay, first what we do, we calculate the forward kinematics. This is the forward kinematics. We use Danavik-Hartenberg matrix. Okay, from this table, we can calculate the, we can get the matrix for H02 and H03. Okay, if you remember, we just change this into a matrix, and then we just multiply all the matrix, and then we can get the n effector matrix. So this n effector is the n position, this, which is this position, the n effector position of our robot arm. So forward kinematics will give the position. Okay, so where can I find the px, py, pz? If you remember from this matrix, kat mana kita boleh jumpa? Okay, because everyone gets high marks, so maybe everyone knows this answer. Okay, So I will divide into 3 people. Okay. Maybe Navin, please find PX. Novatana, PY. And Mahmad, can you give me the PZ? Okay. Novatana, can you tell me what is the PZ for this robot arm?
PY tu PZ apa?
PX, sorry.
PY ke apa?
Novatana PY PX. Apa tadi?
PY
Navin. Navin PX. Okay, Navin, can you tell me what is the PX?
Tak sure doktor, mana satu?
Okay. Novatana, what is the PY?
Yang A2S2 kita.
Okay. Okay, very good, Novatana. So A2S1 C2 minus D3 S1 and S3. Okay, very good. So how about Mahmad? Where is the PZ? What is the PZ?
The PZ,
Mm-hmm.
the A2, S2, D3, C.
C2. So this one actually D1 minus A2 S2 D3 C2. So this one. Okay. So Navin, can you tell me what is the value for PX?
A2 C1 C2 minus D3 C1 S2.
Yes, okay. Simple, eh? So this is the position of our n effector, which is Px, Py, and Pz. So now to calculate the velocity of our n effector, we just need to differentiate with dt. Okay, dt and dt. Okay, so let's do that. Okay, so to differentiate with dt, we need to differentiate. We need to use partial differentiation. Okay, so partial differentiation, simple. Okay, so let's say this is my px. So if I want to differentiate my px with dt, I need to differentiate with all the theta that I have, all the um, the variable, the moving motor. Okay, for our first link have rotational motor, so it is theta 1. For our second link, we have also rotational motor, so theta 2. For the third link, we have d3. So what we need to do is we need to differentiate our px here, we bring it here and differentiate with d theta 1. We differentiate this thing here, we bring it here and differentiate with theta 2. And we bring it here, differentiate with d3. Okay. The same thing for py. We just bring our py here and differentiate with theta 1. Do the same process again. Differentiate with theta 2 and differentiate with d3. So we can get our dpy per dt. And for our dpz per dt, we need to differentiate this thing again. Our px here with d theta 1. Sorry, our pz here, pz, okay? Pz here with d theta 1. Pz here with d theta 2. Pz here with d3. Okay. So to do this differentiation, you need to remember just these two things. Okay. If you differentiate sine, you will get cos. If you differentiate cos, you will get negative sine. Okay. So let's look back to this example here. Okay. So I want to differentiate with d theta 1. Okay. So this is A2, doesn't have anything related for theta 1. This is C1, so cos theta 1. So I can differentiate this one, right? And this is C2. So this is not related with d theta 1. So I just need to differentiate this part. And how about this one? Do we have any theta 1 in this part also? Yes. So we just need to differentiate this thing. Okay. Another example, I want to differentiate this one here with d3. This one here. Do we have d3 here? No. So this will become 0. This one I have d3. So d3 differentiate with d3 will become 1. So this one will become negative C1 S2. So this is the answer. Okay. So what I want you to do is to try to differentiate all of this right now. Okay. After this, I will call 9 people to give you the answer for each of this part. This is number 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I will give you like about 5 minutes. So please, everyone, try to differentiate this equation here. Okay, semua cuba Okay, did you get the answer? Do you need more time? Perlu masa lagi tak?
More time betul.
Okay dah? More time. 5 minutes lagi ya. Okay. Okay, so now I will pick name for each part, each answer, okay? Think okay, so first is Mustika. Mustika number 1. Shazmi number 2. Fatiakan number 3. Muhammad Haris number 4. Number 5, Atira Yusof. Number 6, Muhammad. Number 7, Nur Syuhada. And okay, Rahmat number 7. Hagilan number 8. And Laura number 9. Okay. So yang lain lega lah. Nampak ada senyum eh. Okay. So okay, number 1. Okay, number 1, this part here. So siapa tadi number 1 tadi?
Saya.
Okay. What is the answer? So first we differentiate this one. Okay. So what will happen if we differentiate A2 cos 1 cos 2 with theta 1?
Akan dapat A2 C1 C2 juga.
Okay, because this is cos theta 1.
Oh, cos theta 1.
So if we differentiate with theta 1, what will happen?
Cos akan dapat akan dapat sin.
Okay.
A2 sin theta 1 C2.
C2. Okay. Betul ke? Sin cos will become negative.
Negative sin.
So negative. Right.
So negatif duduk depan.
Okay.
Lepas
Next, this.
tu minus.
Okay, so
D3.
jadi plus. Okay.
D3 plus D3 negative sin.
Okay.
Negative sin. Lepas tu apa ni?
Sin tu je lah.
Sin tu.
Okay. So this one, because of this is negative, so it become positive. So okay. So good. Terima kasih semuanya tadi.
Mustika.
Mustika, sorry. Okay, next saja nak test. Okay, next.
Saya Doktor.
Okay, siapa?
Muhammad Syazmin.
Syazmin Okay.
Jawapan dia negatif A2
Negative A2.
S2
Okay,
Okay.
sebab the cos will become negative S2 and cos
C1
1.
hmm.
Okay.
plus
So how about this one? Plus
S D3 C1 2
C2 kan?
C2
Okay.
C2
If we differentiate sign, we will get cos. Is it negative cos? Well, if we differentiate sign, it will just become
of course
positive cos. Positive sign, positive cos. So this one should be
negative.
negative. Okay. Then senang ya. Okay, number 3.
Ya Doktor.
Okay.
Jawapan dia negatif C1S2.
So this one become 0 Okay. This one negative C1
C1S2.
S2. Okay. So okay, we finish the first one. Okay, correct everyone. Okay, bagus. So number 4.
Saya dah.
Yes. Silakan.
Negatif A2
Okay, negative A2
S1
because this is sine theta 1. If we differentiate sine theta 1 with theta, we will become
cos of
betul. It become cos 1. Kalau sine kepada cos ada negatif ke?
saya boleh cos. Ada.
Okay, kita check sine kepada
Ada.
cos ada. Okay. So this one should be positive lah kan? Dia tak berubah lah. Okay, A2 cos 1 cos 2 kan?
Tu.
Okay, nice. So yang ni pula dia akan jadi
Negatif sin kepada cos. Cos
okay, D3 cos 1 Lepas tu yang ni akan jadi apa?
tu.
Dia jadi sin je lah. Sin 2. Sebab dia adalah 2, kita hanya bezakan pada theta 1 saja. Theta 2 kita tak bezakan. So dia kekal sama. Okay. Kita just bezakan yang ni je. Sebab dia ada theta 1. Okay, faham? Okay. Okay, next. Nombor 5.
Saya Doktor.
Okay, silakan.
Jawapan dia negatif A2
Itu
sin theta 2 sin theta 1
sin theta 2
sin theta 1
theta 1. Okay. Kita bezakan cos ni kepada sin kan? Okay. Minus
minus D3 sin theta 1
okay.
cos theta 2.
So kita bezakan hanya sin theta 2 kepada cos theta 2. Okay, good. Marvelous. Okay. Number 6.
Yes, doctor.
Okay, Muhammad.
Negative A2
Okay.
sin 1
Okay.
negative sin 1
Oh, here. Okay. let's do
Uh,
this again. Let's do this again, Muhammad. So we want to differentiate with D3, right? So
yeah.
do we have D3 in this part here? Can you find?
It would be negative negative A2 sine 1.
So Muhammad, this
Yeah.
one we don't have any D3 here. So if we
Hmm.
differentiate with D3, this one will become 0.
0.
Okay. Yeah. So how about this one? This part here. Do we have any D3?
No.
Yeah. How about this one?
Yeah. We have sine 1.
Okay. So yeah. So if we differentiate this one, this one will become 1. So
1
we will get sine 1,
sine
sine.
1 sine 2.
So it will become negative sine 1, sine 2.
Negative sine 1 cos 1 cos 2.
I don't know. This one we don't differentiate this one because we just differentiate with D3. So only this one will change. The other will become the same. Okay, Muhammad?
Okay.
So what will happen? We just differentiate this one, become 1, and the other part will become the same. So the answer will become
1
S.
S1
S2.
negative S1 1 S2.
Yeah, only that. Okay.
Okay.
Oh. Okay. So finish that one, Muhammad. Okay, thank you very much, Muhammad. Okay, next, number 7.
Saya tu
Okay,
kosong.
so we don't have any theta 1 here because this is D1. We don't have theta 1 here also. We don't have theta 1 here. So 0. Very good, marvelous. Okay, number 8.
Doctor, negative A2.
So this one, there is no D2, D theta 2, so 0. This one will become negative A2
A2.
sine
C2.
or C2 will become cos, right?
Yeah.
Because this is theta 2, so we need to differentiate with sine theta 2. Okay. Okay. How about this one? Next.
Plus D3.
Okay, it will become plus because this one will change to sine. So negative plus D3
S2.
sine theta 2.
Sine.
Okay, nice. Okay, marvelous. Good. Last one, number 9.
Saya Doctor.
Okay. So okay, yes. Please continue with the answer.
D1 jadi kosong.
Okay, good.
Lepas tu yang A2, S2 tu jadi kosong.
Okay, there is no D3 here, so 0.
Negative 1.
So this one is D3, so this one will become 1. Okay.
And cos theta 2.
So the answer will become negative cos theta 2.
Yes.
Okay, marvelous. Thank you very much. I think 8/9 everyone can answer this. It's not that hard. Senang kan? Okay, orang kata kacang, bukan kacang melupakan kulit tapi kacang because it is so easy. Okay. So after we get our new value, so this is our dx per dt. So all of this. This is our dy per dt. And this is our dz per dt. Okay. After we done differentiate, we will write something like this. Okay. And then on the right is the theta. So now theta 1, which is velocity of theta 1, theta 2, velocity of theta 2, and d3, velocity of d3. So dia punya metric dia macam ni So what will happen when we multiply this metric, we will multiply like this kan. So this will multiply with theta 1, this will multiply with theta 1, and this will multiply with theta 1. Okay. So yang ni pun sama juga. So this is just dia punya bentuk lah. This is just the matrix for our Jacobian. How to write the matrix of our Jacobian. So what we have done, we have differentiate this with px per dt, and the answer will be this one here. And dy here, and dz this one here. Okay, itu saja. They very simple differentiation. Okay, now we already have the Jacobian for linear velocity. Okay, yang tadi kita buat is the linear velocity. So linear velocity is x, y, and z. Next, we want to find the angular velocity, which is j omega. Omega is the velocity of roll pitch yaw. Okay. So this part is a bit tricky. Okay. So to get the j omega, so we need to follow this rule. Okay. First, we need to find the sigma for 1, 2, and 3 because we have three moving motor. Okay. Okay. Oh, sorry. Ada budak menangis sekejap. Kita we'll stop like 2 minutes. Okay. So now we will continue for the next part. We can you see my slide? Okay, I think yes. Okay, we already solved the linear Jacobian. Now we want to get the angular. So angular, it depends on our robot. So this robot have 3 degrees of freedom. We have 3 moving motor. So we need to find this one, and this one. Okay. So for the so this is the example. Okay. So our robot, we have H01. We find using DH matrix. Okay. From the DH parameter, we can find the DH matrix for H01, H02, and H03. Okay. For H02, we need to multiply H01 with H12. For H03, we need to multiply H02 with H32. Okay. We have done this for the kinematics. Okay. From this matrix H01, we go for the third column. So this is the angular position. Ingat tak kita belajar? This is angular position. This is the this is x, y, z. So this is the angular position. We want to get the third column only. The third column. So this part. Okay. So the third column for H01 is negative sine 1 cos 1 0. The third column for H02 is this one. This is 1, 2, 3. So negative cos 1 sine 2, negative sine 1 sine 2, negative cos 2. Okay. Because we have three motors, so we need to find the R00, R10, R20. Okay. So saya patah balik tadi. So this is our J omega. So we need to find the sigma. We need to find R00, R01, R20. Okay, kan? So ni adalah one motor, two motor, and three motor. Because we have three motor, we just need to find these three. Okay. To get R00, we just use this value 001. So this is default. Dia sama untuk semua robot sama. So we just put this value here as 001. Okay. So for this part here, okay, R00 is 001. How about the sigma? Sigma depends on our robot motor. If our motor is rotational, the sigma will become 1. If the motor is prismatic, it will become 0. Okay, ada dua je. Revolute 1, prismatic 0. Okay, for our robot, okay, let's go back to our robot here. Theta 1 is apa? Revolute. Dia pusing kan? So revolute or rotational. Theta 2 is also revolute. Dia rotational. So sigma 1 equals to 1, sigma 2 equals to 1. Dan untuk motor ketiga, the third motor is prismatic. So prismatic sigma 3 will become 0 sebab dia bukan rotational. Okay, so macam tu saja, dia ada 0, 1. So now we just put all those value here. So sigma 1 is equal to 1, sigma 2 is equal to 1, and sigma 3 is equal to 0. Next, I want to find what is my R01. So I go to H01 matrix and I go to the third column. So 1, 2, 3. So this is my R01. My R01 is equals to negative sine 1 cos 1 0. Okay. And my R02 I can find from H02. So I go to the third column, 1, 2, 3, and I get this value here. So I will put it here, negative sine cos 1 S2, negative sine 1 S2, negative C2. Okay, if I multiply this one with this one, I will get apa? 1 darab dengan 001, we will have 0, 0, 1. Okay. 1 multiply with negative sine 1 cos 1 0, I will have negative sine 1 cos 1 0. 0 multiply with 0, I will get 0 darab dengan 0, we get 0, 0, 0. So finish. This is my J omega. Okay. So my final Jacobian, I just need to add my JV. If you remember, JV is equals to dpx per dt, dpy per dt, and dpz per dt, which is equals to this one. Okay, that is JB. And J omega is this part here. So JB we put on the upper part, J omega on the lower part. And then finally we will get our Jacobian matrix. So this is our Jacobian matrix. So this is the final answer. So I want to emphasize again, there is only 3 steps, okay, to get Jacobian matrix again. So Jacobian matrix. Buang sikit kan. Okay, there is only 3 steps to get Jacobian matrix. First, we get the forward kinematics of our robot. Okay. From the forward kinematics, we find the px, py, and pz. Second, we differentiate the px, py, and pz. And the third part, we just need to find the j omega. Okay. So we use the third column of the rotation matrix, which is R01, R02, and until n effector. If the joint is rotary, so the sigma will become 1. If the joint is prismatic, the sigma will become 0. So that's all for the Jacobian matrix. So there are 3 steps, okay? There are 3 steps to get Jacobian matrix. Okay, we have come to the end of our class. So now we are open for Kahoot. Okay. Oh no, we still have another part. Okay, sorry. Okay. So when we try to find our robot Jacobian, we need to always remember there are 2 conditions that we cannot calculate our robot Jacobian. Kita tak boleh kira kita punya Jacobian disebabkan these 2 problem. Okay. Disebabkan masalah benda ni kita tak boleh. So Jacobian ni berlaku bila adanya singularities. Saya tunjuk singularities, macam mana singularities boleh berlaku. So how come we have singularities? Okay, please look at my screen. Okay, singularities berlaku happens when we try to move our arm robot. If I have my arm robot like this, okay, I want to move my arm robot this way, okay. If I want to move my arm robot this way, okay, we will have a joint lock. Dia akan jadi macam joint lock. Robot tu dia tak boleh. Dia akan berhenti. So this is what we call Jacobian singularities untuk kita punya Jacobian. Dia tak boleh jalan macam ni Sebab when the robot try to move this way, there will be like infinite force. Okay. Sebenarnya boleh je if we bengkokkan, if we bend this joint here a little bit, then we can do Jacobian velocity calculation and we can move our robot this way. Okay, like that. But if our robot is straight like this, it will be joint lock. So if we try to calculate our robot to move this way, the robot cannot move. It will stop. So that is called Jacobian. We need to avoid our robot from having this kind of condition. They lock, then dia tak boleh turun. So this is just a mathematical calculation problem. Okay. To avoid it, we just need to bend our robot joint a little bit. Okay. So there are 2 types of singularities. One is boundary singularities. Second is interior singularities. Ada 2 There are only 2, boundary and interior. Okay. Boundary, it is the most general singular configuration for robot manipulator. Is when the tooltips is on the surface of work envelope. So which mean kalau macam ini robot arm saya. So my arm robot boundaries is here. The robot cannot move further than this location. Okay, this is the furthest distance my robot arm can go. If I say my robot arm to move around this area here, we will have singularities. The robot arm cannot move anymore. Bila dia sampai kat boundary je, kita nak gerakkan dia, dia dah tak boleh dah. So that is one of the problem of boundary singularities. Okay. So another condition, interior singularities. Interior singularities macam yang saya sebut tadi lah. Interior singularities bila kita punya robot arm tu di straight, kita tak boleh nak bendkan dia dah lagi. Okay. So that's all. Ada dua je condition bila robot kita sampai kat boundaries dan bila robot kita di tangan ditegak.